within your academic publications, for example, obviously you came from that sort of engine anomaly detection, the mechanical type approach. I came directly when we met, directly from the patient monitoring side. And yet, for example, a lot of our citations and papers were on the same people because you had been citing my supervisor my academic grandfather in that regard, which is, again, one of those things where it's funny how a lot of these techniques revolve around a certain hub. So that connection was there originally.
I think your supervisor was originally working in machinery condition monitoring directly, wasn't he?
Yes. Yeah.
So I do remember. Yeah, you're right. There was definitely citation crossover amongst the kind of the publications we were looking at and contributing to as well. Mm-hmm. It's interesting though. I'm not sure. I mean, from a methodological perspective, you can see why there's a confluence between those two. At the end of the day, it's time series you're looking at. I mean, very different physical processes, the human body versus a turbine generator. Those things probably couldn't be more different, but it does seem that there's an interesting aspect to this as well, that fair enough, those domain areas are very different, but the toolkit that you use is very similar, and the way you solve the problems is very similar, which again is something that we're seeing in data science. There's a set of kind of key skills that data scientists will have, and those will apply almost domain independent to a lot of software problems. If you've got experience working with time series, then there will be a lot of time series problems in software teams that you could potentially solve. So it's interesting how there's that overlap in academia as well as seeing that in the real world, so to speak, as well.
Yeah, I think there's good reason why there's such an overlap in, for example, like turbine monitoring and patient monitoring, and the examples are one. And I think this also relates to why we can be very hopeful about a science over data analysis. So for the people who like the term data science as a scientific approach to data analysis, and a scientific and inductive understanding of, data and methodological combinations, which is another definition I like. I think it's just sort of different from the other. I like two definitions and they're fairly orthogonal. So something like a principal components on data science. But there are reasons to understand why these two things overlap so much in the methods, and because one, they are time series, they have a high density of observation. Those observational time series, or those not observations, they're like data acquisition. So they're very dense. They have steady state processes. The non-steady state processes they have are typically well understood, or at least essentially they follow certain they follow sort of certain archetypal data anomalies and things like that. And so essentially you can have steady state, and you can have a well quantified steady state, and then deviations from that steady state follow certain archetypes, and then you can do analysis around there. So I think it's one of those things where and obviously there's also a high value in making sure that both those things keep on working, airplane engines in human bodies, or mechanical engines in human bodies. So yeah.